Okay, so I'm going to go over a little bit about word problems again. So we're going to start off with how to actually do a word problem and what to do and how to set it up and um, you know define our variables and all sorts of things. All right, so the first thing we want to do is read this thing. We have a premium salad mix, which costs $5 a kilogram. It's made by combining rugula, which costs $6 a kilogram, with spinach, which costs $2 a kilogram. Find the number of kilograms of arugula and spinach required to make 16 kilograms of premium salad mix. All right, so what are we going to do here? So let's figure this out. So first of all, we've got again, what I taught in class was let's make the variables equal to the things we're looking for. So we're going to make x equal to the kilograms of the arugula. I believe that's a type of lettuce. And then we're going to make y equal to the spinach. Kilograms of spinach. Okay, so then now that we know what x and y are, what we're going to do now is, what I taught in class was kind of make these little containers to kind of, well, kind of remind ourselves that we are doing a mixture. We're just kind of mixing things together. And then underneath it, we put our either dollar amount or percent. And here we're doing dollars. So this will be dollars here, and then dollars here. Now remember that the right side here is the final mix. Alright, so just keep in mind that the right side's the final mix, and on the left side are all our two mixes together. So what the reason why you want to set this up is because when you read the problem again, you're going to be able to kind of put in the numbers as you go. Let me change color. All right, so we're going to all right, so anyway, we look at this premium salad mix, which costs $5 $5 a kilogram. All right, so whoa, what happened? Basically, we're looking at this thing costing us $5. All right, that's the premium mix. It's made by combining the arugula, which costs $6. And remember, we made X arugula. First of all, putting my $6 in here and my $2 in here. Okay, so that's my spinach and my arugula. Again, we know that X and Y are our variables. Okay, again, the boxes are supposed to account for things, how much of something, not how much it costs, not percentage-wise, but what amount in terms of kilograms. And then we know that we need to make the mix of 16, so we put that 16 here. So when we're solving this, and again, I'm not going through the whole solving process. I'm just this is just to help you set up the equations, because the solving part would be in a different video. Alright, my first equation is going to be x plus y equals 16. This deals with the amount. How many kilograms in the entire thing do I want to make? I only want to make a total of 16. So I don't want to exceed 16. I'm only allowed to be 16. So between the two of them, they can only have 16 kilograms. So that's what my first equation is so important. And my second one has to do with cost. So it costs me $6 for every kilogram of arugula. It costs me $2 for every kilogram of spinach. And then the last part, the cost of my final mix, is 16 times $5. Okay, so again, my two equations will be x plus y equals 16 and 6x plus 2y equals, what is that, 80. Okay, and then you would just solve these two equations. Again, see another video for how to solve systems. In this particular case, I would use, most likely use substitution, but who knows. You can use whatever you like at this point. Alright, so we're going to go on to the next equation. Okay, Rob wants to make 7 liters of 5% sugar solution and mixing it together with 35% sugar solution and pure water. How much of solution must he use? All right, so we're gonna make X equal to, let's see, 5% sugar solution and 5% sugar, right? Oh wait, that's wrong. Skip that. Let me reverse that. 5% is what I want to do. How much of each solution? So the solution types I have are 35 and then water, which we'll talk about in a second. So we're going to let X equal to 35% sugar. And then water, pure water, is technically 0% sugar. Okay, everything's about sugar here. Alright, so when we set this up again, we do the little containers. Okay, we got our percents down here, just like we practiced. Okay, and then we fill it in as we go. Alright, so we have X. Let me change color just because it's a little bit more interesting. Let's do that color. I don't even know what I'm going to get here. But alright, so there's X here, Y here, and again, we got to fill that part in. And then we have percentages. We've got 35% here, 0% there, and then its final solution needs to be 5%. Also, keep in mind, Rob wants to make 7 liters, so that 7 is going right there. Okay, so again, you read over the word problem real quick. Make sure you've got all the pieces of information somewhere in here. Alright, so I've got my 7 there, got my 5% there, got my 35% there, and we got water. So basically we're watering this down, and we're watering this down quite a bit. If you notice, we started with 35%, we mixed a lot of water, and we're only down to 5. So we can pretty much guess we're going to be doing a lot of water. So when you finally do solve this thing, you're watering it down quite a bit. You should have a good amount of water going into this. But anyway, to do the equation, first one again, what's in the boxes? Second one is percents, and I tend to leave my percents alone on these because of the fact that everybody's percent. And again, if everybody's percent, then you don't really have to worry about switching it over to decimals. Okay, so this is 35x. This comes out to be nothing. Alright, so that's like no y. If you want to put in there, you can, but basically that drops out. And then this is 35. Alright, so again, this is the math's going to be, it looks like it's going to be pretty easy on this one. So I can even see what the answer is going to be to that one already, but just by looking at it. But you're going to use this equation up here, x plus y equals 7, and then you'll use this equation there and solve it. And as you can see, you can probably eyeball it. If 35x equals 35, then x is equal to 1. And so you're going to put 6 liters of water in it, which I told you you're going to put a lot of water in to water it down from 35% strength down to 5%. Okay, you're watering it down. Alright, so let's go to the next one. Let's see. Oh, this is really small. But anyway, Yellowstone National Park is a popular field trip destination. This year, the senior class at High School A and senior class at High School B both planned trips there. The senior class at High School A rented and filled 7 vans and 11 buses with 566 kids, and in High School B rented 4 vans and 10 buses with 498 kids. Each van has the same number of students in it as did the buses. Find the number of students in each van and each bus. So they filled up everything. Alright, so since I'm asked to find the number of students in the van and the bus, that's what I'm going to make my variables equal to. X equals number of students on in van I should probably say, but y equals the number of students that one would be on. That's kind of weird to be in the van but on the bus. Whatever. Alright, so I got those two. Now, these are pretty actually a lot simpler than the other ones. It's not really a mixture problem per se, so all I have to do is read, and as I'm reading, I write. So the first one says that the senior class high school rented 7 vans and 11 buses. So I want to do um, seven seven vans, each with a number of students on it, plus 11 buses. Okay, the number of buses, and then that's going to total 566 students altogether. Remember, X and Y are students. So 7 buses, or seven vans, each with a bunch of students in it, plus 11 times a certain number of students in it for on the buses, gives you 566, and then you just do the same thing with high school B. There are 4 vans and 10 buses, and that holds 498. And again, there's your two equations, and like I said before, if you have two unknowns, you must have two equations. And there you go. And again, I would solve this by elimination, but I'm not going to because, again, that's a different video. All right, last one. All right, plane traveling. This is one of my favorite ones to do because it's fairly easy. Plane travels 3,040 miles from Abuja and back. The trip there was with the wind. It took 16 hours. The trip back was into the wind, so the trip back took 20 hours. What's the speed of the plane in the still air, and what's the speed of the wind? All right, so again, I would make x equal to the speed of the plane, and then I would make y equal to the speed of the wind. All right, so this whole entire problem is relying on d equals rt, which is distance equals rate times time. So distance there was 3,040. Now the rates, if you're traveling with the wind, that means your speed is being increased by the wind. So we're going to add our two speeds together. Okay, the rate of the plane plus the rate of the wind, the speed of the two being added together. It speeds it up. And anyone knows if you've flown a flown in a plane, that when you fly with the wind, you get there faster. And then if you came the same, so if you did a round trip, it would actually take you less time to go one way versus the other. All right, and it took me 16 hours to get there. Then on the way home, which is still 3,040 miles, this time the wind is against us, so it's literally going to slow us down. So that's why you're going to subtract the speed of the plane minus the wind. And again, I did it in that order because the wind should not be faster than the plane. So I'm safe to make sure I get a positive number here. And again, it took 20 hours. And again, this is the setup is all this video is about. So there's your setup, and you really are ready to rock and roll. Now to solve this thing, I would start off to see if I could divide 16 into 30, 40, or 20 into 30, 40 if I could. That makes my equations quite small, and then I could just use elimination right here and get rid of my y's. That's how I would do it. And I think I'm done. Yes, I am. So hope this helped.